All right, today we're going to be talking about section 7-3 for polynomials. There are two main ideas in this section. First one is finding the degree of the polynomial, and the second one is arranging it in either ascending or descending order. Okay. First, we want to talk about some vocabulary. Okay. So you have your prefixes, mono, bi, and tri. Okay. So anyone who's had language arts knows we have 1, 2, and 3. So mono, you can think about the word monopoly. So monopoly means a company, one company that has taken control over an entire industry. Bi, think about bicycle, has 2 wheels. Again, tricycle or triangle, 3 angles, 3 wheels. Okay, so we're going to apply these to polynomials. Okay, so in the polynomial family, you have monomials, you have binomials, and you have trinomials. Okay, so let's review the word monomial. Okay, so very first thing, we talked about monomials in section 7-1, and we said a monomial could be either a constant, a variable, or the product of the two. Okay, so some examples are, you're looking at 7 or 7x or x squared. Any of those are monomials. Okay, binomials are just two monomials put together. Okay, so you're looking at maybe 7x plus x squared. Okay, this is a monomial, this is a monomial, and they're attached together through addition. Okay, a trinomial are 3 monomials. So you can have maybe x to the third plus xy plus 3 plus y, whoops, 1, 2, and 3. Okay, so the polynomial family is inclusive of monomials, binomials, and trinomials. So if you are a trinomial, you are also a polynomial. If you are a binomial, you are a polynomial. If you are a monomial, you are a polynomial. Okay? So, very important thing to point out too is that binomials and trinomials are, you can say they are put together by either addition or subtraction, which is basically the same thing. You're adding the opposite if you're subtracting. Okay, so let's talk about which is which. Okay, so here is a table. I'd like for you to write this down and to fill in whether this expression A, B, or C is a monomial, a binomial, or a trinomial. Okay. For the very first one, A, you should get this as a coefficient multiplied to a variable. Okay, so that means that is a monomial. Okay. For B, looks like 2 monomials put together by addition. So this is a binomial. Okay. For C, you have 1, 2, 3, 4 terms, but take a look at this. We can combine these two terms to make negative 3y squared plus 2y minus 1. We're simplifying this. Now what you see here is a trinomial. Okay, what did you get for D? Okay, if you're looking at this, remember, very important, x to the negative 4 is 1 over x to the 4th. Okay, and if you have 1 over x to the 4th times 10 minus 8 x to the 3rd, you can simplify this. It would look like this. Very important to remember what the definition of a monomial is. Okay, because you're looking at this term, this would not qualify as a monomial. Okay, look back in your notes. Do you see why? Your variable here is being divided. We said monomials are the products of variables or variables and constants. Okay, this is not a product, this is a quotient of variables. So this is none of the above. It's not a monomial, it's not a binomial, it's not a trinomial. It is not a polynomial. Okay, reviewing a few more things. First thing we said we were going to focus on is the degree of a monomial. Okay, a degree of a monomial is the sum of the exponents of all its variables. So let's take a look at the first example. You have three variables here, x, y, and z. And we said the degree represents the sum of all of the exponents of the variables. So let's take a look here. X has 2, y is 3, and z, you don't see it, but there is 1. So if we were going to sum up all the exponents, the degree would be 2 plus 3 plus 1, which is 6. Okay? And this is a monomial. Okay? Let's do another example. You try this one. 64. Okay, did you get it? We have to be a little creative with this one. Okay, there's no variable here. If there was, let's say if there was a variable here, it would have the exponent of 0, because x to the 0, y to the 0, any variable to the 0 power is just 1. 64 times 1 is what you're seeing here. So the degree, this is a monomial again because it is a constant. So the degree of this would be 0. Okay. So we talked about degrees of monomials. We obviously need to talk about degree of polynomials now. Okay. So a polynomial can be a monomial. It could also be a binomial. It can also be a trinomial. So let's take a look at the rule. For a polynomial, you're looking for the highest degree of any term in that particular polynomial. Okay, what does that mean? If you have an example like this, you have to take it term by term, which means here's your first term, here's your second term, and here's your last term. This is an example of a trinomial. Okay, and the degree would be, we have to look at each term separately. Okay, here we have 3 and we have 2. So the degree of the term number 1 would be 5. Here we have m. You don't see an exponent, but you know that it is 1. So you have 1, you have 2. The degree here is 3. The degree here, there's no variable. If there was, say there's an m here, it would be to the 0 power. So your degree here is 0. Okay, and again, for polynomials, like trinomials, you're looking for the highest degree of any term in that polynomial. So you're looking for the biggest number. So degree here would be 5. Okay, you try it with this example. Okay, degree here for the first term is 2. Degree for the second term, 1 and 1, 1 plus 1 is also 2. So the degree for this binomial, there are 2 monomials attached by addition, is 2, the highest number. Okay? So we need to move on now to writing polynomials in order. Okay, when you write your polynomial, there's always a specific order that you need to write it in. Okay, and there are 2 ways to write it. You can write it either in ascending order or in descending order. Okay, and first I want to review what these words mean. You have the word ascending, okay? And I always think of it as A. When you write A, you're going up with your pencil first. And also the grade A means that your grade is very high. It's going up, okay? So this is going up in order, okay? When you're descending, it's like you're going down, okay? Descending equals going down. Okay, and this is really important to know the difference between ascending and descending because you're going to have to read the instructions very carefully. Okay, when you're doing this, for example, you're given this polynomial, y squared plus 5x to the third minus 3x squared times y. The instructions first may ask you to arrange the powers of x. Okay, I'm going to underline powers of x. Okay, actually box it. Powers of x, and we want in ascending order first. Okay, so take a look at these. Take a look at the terms. You have y squared. You have a positive 5x to the third, you have a negative 3x squared y. There are 3 terms here. You're most concerned about the powers of x, okay? So take a look at the first term. What is the power of x in y squared? Well, there is no x. So what you're really seeing is y squared x to the 0 power, okay? Take a look at the second term. You have 5x to the third. And then the last term, you have 3x squared, okay? Now, you're focusing in on the powers of x. Take a look at the powers of x. We want to put these in ascending order, which means they're going to go up. They're going to start at a very low number, and they're going to go up. So the order that you should have, this one's going to go first. This one's going to go second, and this one's going to go third. So when you write your polynomial, you should write y squared x 0, or just y squared actually, minus 3x squared y plus 5x to the third. Okay, now your powers of x are in ascending order. They're going up. Okay. You may also see directions where you are asked to arrange the powers of x again. Be careful because sometimes they'll ask for a different variable. So powers of x in descending order. Descending order. So you want to make sure that the terms, the exponents are descending. Okay? Which means here you would start with the highest power. You'd have 5x to the third. Okay, the next highest power is x squared, so minus 3x squared y. And the lowest power is x to the 0, which is just 1, so you'd have plus y squared. Okay, so 2 things to make note of. You need to look at which variable you're asked to order, and you need to find out if it's ascending or descending. Okay. So the very last piece is the geometry connection. Okay, so the objective here is to write the polynomial to represent the area of the shaded region. So go ahead and draw this picture in. If you recall, to do this problem, you're going to need to understand how to find areas of various shapes. Okay, so we're talking about area, and what shapes do we have here? This looks like a rectangle, and I know my drawing's a little off, but imagine that this is a semicircle, and this is also a semicircle. Okay, a rectangle here has the length of C and the width of 2D, which means this is also C and this is also 2D. Okay, So if I want just the area of the shaded region, I'm going to start off with what my whole piece looks like. My whole piece is the area of the rectangle. Okay, an area of a rectangle I know is length times width. Okay, and looks like we have also semicircles. Well, if I have one semicircle here and it's the same diameter, I have a semicircle here that's the same diameter. Looks like I could put it together and it makes a circle. And I know that the area of a circle is pi r squared. Okay, so these are the two pieces of information we need to know in order to set up our equation. Okay, so here's what we have so far. Okay, I'm going to start off with the area of my rectangle. Okay, that's the entire shape. And what I'm going to do is I'm going to subtract the area of the two semicircles. Well, the two semicircles makes up a full circle. So I'm going to subtract the area of the circle, okay, to get the area of the shaded region. Okay, so all we need to do now is to fill in the missing pieces. Okay, and to do that, we go on the next page. So we had the area of a rectangle minus area of a circle will be area of the shaded. Okay, area of a rectangle, length times width. Area of a circle is pi r squared. Okay, equals our shaded region. Well, the length we said was c. The width we said is 2d, and we're going to subtract it by pi. I'm going to keep pi. R, radius, okay? We know the diameter of the circle is 2d. Radius would be half that value. So the radius is 2d divided by 2. And this value needs to be squared in order for us to get the area of our shaded region. So let's simplify these just a little bit. C times 2d, I'm going to put the coefficient first, make sure it's in alphabetical order, 2cd, minus, okay, 2 divided by 2 is just 1, so that's d squared times pi. And so I'm going to use the commutative property, and I'm going to put d squared first, and then pi will be equal to the area of the shaded region. Okay, so here you go. This would be representing the area of the shaded region as a polynomial. Okay, for your practice tonight, I'd like for you to work on textbook page 378 and 379. You're going to do numbers 1, 5, 7, 8, and 10. Okay, 1, 5, 7, 8, and 10. Okay, bring that back tomorrow and we will discuss it in class.